All right, let's dive into something truly fascinating today, the hidden connection between epilepsy and schizophrenia. Now, on the surface, these two conditions seem like they're from completely different worlds. One is about electrical storms firing off in the brain, and the other is a disorder of the mind itself. But as we're about to see, they are tangled together in some really surprising ways.
So that's the central question, isn't it? How can seizures, these chaotic bursts of electrical energy, possibly be connected to something as complex as psychosis? It's a real puzzle, one that makes us question what we think we know about how the brain works. And let me tell you, the answer is anything but simple.
And, this isn't some brand new discovery. This is a connection that scientists and doctors have been wrestling with for over a century. They've long suspected that cracking this puzzle could be a major key to understanding both of these incredibly complex conditions.
Okay, before we go any further, let's get a key term locked down. We're going to be talking about schizophrenia-like psychosis, or SLP. Now, this is super important. This is not just another name for schizophrenia. It's a very specific kind of psychosis that is directly linked to having epilepsy. Making that distinction is absolutely crucial.
So, is this link just an interesting coincidence that doctors have noticed over the years, or is there some real hard evidence behind it? Well, let's stop speculating and actually look at the data. The numbers tell a pretty dramatic story.
Get this. A massive study out of Denmark, a really comprehensive one, found that if you have epilepsy, you are almost 3 times more likely to develop schizophrenia-like psychosis. That's not just a small statistical blip. That's a huge flashing neon sign telling us there is a powerful connection here that goes way beyond chance.
And to put that in perspective, just look at these numbers side by side. Schizophrenia in the general population, it affects maybe 1% of people. But for those with epilepsy, the rates of SLP are just dramatically higher. The evidence is pretty undeniable. So the question is no longer if they're connected, but how. What in the world is going on?
To start unraveling this mystery, we have to get a little more specific. It's not enough to know that psychosis occurs. We need to know when it occurs in relation to the seizures. As it turns out, the timing gives us some of our biggest clues.
Researchers have broken it down into 3 main types. First, you have ictal psychosis, which happens, unbelievably, right during a seizure. Then there's post-ictal psychosis, which shows up in the hours or even days after a seizure is over. And finally, you have interictal psychosis, which is a more chronic, long-term state that exists in the periods between seizures. This complexity alone tells you it's not a simple one-to-one relationship.
And this is where the story gets really, really weird. It turns out that seizures and psychosis seem to have this bizarre, almost antagonistic relationship. It's a phenomenon that is so deeply counterintuitive, it's honestly mind-bending.
So picture this. It's the 1950s, and a researcher named H. Landalt is monitoring the brainwaves of his epilepsy patients. He's seeing the typical chaotic, spiky patterns on the EEG. But then, when one of his patients enters a psychotic state, he looks at the machine, and the brainwaves have become, normal. It was bizarre. This phenomenon was named forced normalization. And here's the absolute kicker. It means that sometimes, when doctors are successful, when they find a treatment that stops the seizures, they can actually, paradoxically, trigger a psychotic episode. By calming the brain's electrical storm, they can accidentally unleash a storm of the mind.
You can think of it like a seesaw. When seizure activity goes down, the risk of psychosis goes up. They're pushing against each other. But how is that even possible? How can fixing the seizures actually cause psychosis? It seems to defy logic.
Well, the answer just might lie in something called the vulnerable brain hypothesis. It's a theory that beautifully ties together all these strange clues, the high numbers, the specific timing, and even this wild seesaw paradox.
The central idea is actually pretty elegant. What if it's not that seizures are causing psychosis or vice versa? What if instead they are both just symptoms of the same, deeper, underlying problem in the brain's structure or function?
This model proposes that some people simply have a vulnerable brain. Now, this could be due to something that happened during development before they were born, or maybe from an injury or an infection later in life. The point is, this fundamental vulnerability doesn't just create one problem, it creates a brain that is predisposed to developing both epilepsy and psychosis.
And here's how that might play out over time according to what's called the composite model. First, you start with that initial vulnerability. That vulnerability then leads to the development of epilepsy.
But, and this is the critical part, over years and years, the repeated seizures themselves actually cause further physical changes to the brain's wiring, and eventually, all those little changes add up and disrupt major functional systems, reaching a tipping point where psychosis finally emerges.
So, in this model, seizures play a fascinating dual role. They are a symptom of the original problem, for sure, but they also seem to act as a kind of biological brake on the psychotic process. And that explains forced normalization perfectly. When you medicate the seizures away, you're essentially taking your foot off the brake, allowing the underlying psychosis that was always there to finally surface.
So, what's the big picture takeaway here? Why does this strange, complicated relationship matter so much? Well, it's because it gives us a unique and incredibly powerful window into one of the most profound mysteries in all of psychiatry.
The bottom line is this: studying schizophrenia-like psychosis in epilepsy isn't just about understanding a rare subtype of a condition. It's giving us a real-world, human model that could help us finally understand the fundamental biological mechanisms of schizophrenia in the general population. It's a potential key to unlocking a much larger puzzle.
What this all shows us is that the brain's disorders aren't siloed off in neat little boxes. They're deeply interconnected, woven together in ways we are only just beginning to appreciate. And it leaves you with a really provocative thought, doesn't it? If the study of epilepsy can act as a kind of looking glass into the mystery of schizophrenia, what other secrets about how our own minds work are just waiting to be revealed inside the brain's incredible, intricate wiring?